So the next that we are going to look at is the magnetic flow meter. So the magnetic flow meter actually uses the law of electromagnetic induction. We all know from Faraday's experiment that if a conductor moves through a magnetic field, an electric current is induced in that conductor. Okay, so in this our case, the conductor now is the fluid, which means the implication of this is that the fluid must be conductive for us to be able to use our magnetic flow meter. Okay, so we'll say the magnetic field created by this permanent magnet, these are the magnetic lines of fluxes. So as the fluid is flowing through, you see these electrodes, okay, the fluid will momentarily at that point complete the connection, and since voltage or electric current has been induced in it, it will run through this circuit, because it will at the end of the day close the circuit, and then you have your reading. So the rate of that induction of the electric current, okay, or the magnitude of induction is determined by the flow rate. So the higher the flow, the higher the amount of induced voltage on this circuit. So with that, we can calibrate the flow meter, okay, since it's getting voltage signal, to give us a direct reading of the flow of the fluid through that section of our pipeline. So that is what we are seeing here too. So as you can see, you see this is the conductive fluid that is flowing through the section of the flow meter. So you see as the flow is increasing, just watch what happens to the flow meter. You see that the voltage induced, the voltage induced will be increasing. As the flow reduces, the voltage induced comes down. Okay, so which means that we can calibrate the voltage that is induced here to give us a direct reading of the flow rate of the fluid through that section of the meter. So this is an example, physical example of the flow meter. This is how you see it, and this is one that is installed in the field physically. Okay, so like this flow meter now does not place any restriction on the flow path of your fluid. Are we getting it? But the fluid must be a conductive fluid. So in most cases, they apply them for slurries and conductive fluid, which means we cannot use it to measure the flow rate of non-conductive fluids like hydrocarbon.